Hey guys, what's going on? So today we're going to be talking about the internal pullback in quantum gravity. So last time we talked about the external pullback, where we sort of alluded to the canonical momentum for our theory of quantum gravity. Now we're going to take a look at this a little bit more, not so much taking a look at the canonical momentum, but we're going to be trying to understand, just cut into the chase here, how we can formalize this in terms of something that looks like a Yang-Mills theory, okay? And then we're going to have to talk about Yang-Mills theory a little bit, and then we're going to have to talk about, but before we talk about Yang-Mills theory, we have to talk about Maxwell's theory. So this is going to be sort of an intro to two sort of large debriefs on Maxwell's theory and Yang-Mills theory, and then we're going to circle back and talk about quantum gravity and how these things all sort of look like each other and sort of has similar dynamics. Okay. With that being said, I've been a little bit late in posting some of these videos. I understand. However, things are hopefully going to be starting to pick up again, and I have a few more ideas. I'm going to continue with the GR playlist. I understand I sort of stopped on that front a little bit. I want to keep on doing that. I also want to do some more biologically relevant things because my PhD is in biophysics, and I kind of want to touch those areas as well because I have a lot of expertise in that field also. So with that being said, make sure to hit that like, subscribe button, go onto my Patreon page if you want to support the channel, and also a place where you can get full videos. Again, here in these videos that say free version on the thumbnail, you only get a small portion of these videos. You can go onto my Patreon and get full versions. You can go on to, or you can also become a member here and get full versions as well on YouTube. So let's get started. So thus far, we have been developing an action for our quantum theory of gravity. In this pursuit, we have attempted to make our action a self-dual action, and in doing this, we defined the self-dual part of this of the spin, or the internal connection, and we densitized it, and then called this one of our canonical variables. We then found that the canonical momentum to the self-dual part of the internal connection is the densitized spatial part of the square root of the metric. Okay, we talked about that before. Let's sort of debrief on this a little. Just come back at it again, just briefly. We had this guy here, which was our canonical variable. So our canonical variable, and that was related to the self-dual part of the internal connection. Okay. And then we had our canonical momentum, it's this guy right here. All right. And our canonical momentum was related to our triad. Right? So our triad is the spatial part of the square root of the metric, and the square root of the metric is the tetrad. You notice how a few sort of things here. One is that the internal indices, these guys, are opposite of each other, right? So one is contravariant, the other is covariant. And we also notice that we have the opposite is the same for external indices. Right, so in the external indices and the internal indices, right, so one touches the one touches space-time, okay, the other one doesn't. Internal indices touch things like spin, color, and that kind of stuff, whereas again, spin and color, they don't necessarily touch, they're not necessarily functions of space-time, right? Those are separate indices. We sort of liken that to a roller coaster, right? So the roller coaster traveling in what seems to be a one-dimensional line. If you look at it from a far distance, well, it could also be rotating along that one-dimensional line, and so that rotation in one dimension can be thought of as internal space within a one-dimensional space, right? So, and that sort of relates back to fiber bundles and all this kind of stuff as well. But we just kind of want to look at these, and we want to say, okay, well, one looks like the opposite of the other ish, and it sort of depends on what you mean by opposite, but this is what they are, okay? So a useful thing worth noting about these variables is that they both share somewhat of a dual nature to each other. In the case of the connection, the internal spatial indices are contravariant, and in the canonical momentum, the internal spatial indices are covariant. It's also worth noting that the self-dual connection will come to look like an internal analog to the electromagnetic field tensor. We are now going to explore the gauge freedom of the normal vector to our hypersurface. Recall that during the ADM formalism, we constructed a way to foliate our spacetime so that our normal vector